All right, new package in the mail. This just arrived. It is a portable power station from Maxoak. It's their newest version. They sent one to me for review. We're going to test what it can power, what it can't power, its limitations. We're going to see how much usable capacity it is. And then we'll mention what kind of applications might be good for this if you're thinking of buying this model. So let's get going. Hi, I'm David and welcome to my channel where I like to DIY renewable energy and energy efficiency projects. However, this is not a DIY project. Sometimes it's actually less expensive to purchase a pre-made unit, but only if it works for your needs and your applications, which is what this video is for, to find out if it works for you. Well, portable power station from Bluetti, 2,000 watts and 2,000 watt hours. Warranty manual. We have a wall charger. Here are the accessories that came with it. We have MC4 connectors to an XT90. We have an accessory port for cars. I used to call these cigarette lighters when I was growing up. And then this is the part that will go into the Bluetti, in the back of the Bluetti. And then it has the receiving end of the XT90 for all of these. And a big wall charger. Oftentimes these wall chargers are kind of wimpy, but this one looks like it can be used anywhere in the world, 100 to 240 volt, 50, 60 hertz. So 58.8 volts is fully charged for lithium ion cells in a 14S configuration. On the back of the Bluetti, it is the AC200. It says 50 volt, 40 amp hour, 2,000 watt hour battery. Now I'm really pleased to see that the PV input has been upped to 150 volts DC. That's really awesome. Working temperature is to 0 degrees Celsius, that's freezing. Cooling fan, we have, this is the input there, and input for the barrel plug. So this is specifically just 58.8, and this one is going to be your input from your solar or your car. Top of the unit has 2 spots to charge your cell phone. Here we go, let's power it on for the first time. Oh, it's a nice looking screen. Quite a bit of information they're sharing there. So 6 standard USB, standard USB, USB-C with power delivery, that's the PD. So barrel plugs and adapter. So it looks like the adapter can do 10 amps, and these little barrel plugs, if you have something that takes them, they're going to be 3 amps. They also have a 25 amp output, but that would take this style connector, but in the male form, and I don't have that accessory, so don't know if it's something else you can buy from Bluetti or how easy that is to find. Came with 37% charge. We'll give it a little bit more with the included power pack. So this is plugged into the wall. Let's see what it does. There it goes, I just heard it click. Now it's taken it. This is probably going directly to the battery, to the BMS, whereas this input is going to an MPPT charger, which is probably a good thing. It means that this overall would be more efficient. Instead of going through the charger port, we're going directly to the battery, probably still with the BMS in there. I've had this charging for probably a couple hours. We've gone up from 37% to 87%. We're not fully charged yet, but this is getting hot. So I wanted to show you the temperature. 145 Fahrenheit, 63 Celsius. So that is pretty toasty. I just found something on this little screen. I went to data and there's a BMS in here, and it's now telling us what the battery voltage is. So we've got 6.4 amps going in, and 77 degrees Fahrenheit inside. So the battery itself is not having any problem. It's charging. That's awesome. If we go to next, it actually tells us what the voltages are. Well, that's really fantastic. Now it looks like we have 16. So this is a lithium iron phosphate. Now seeing 16 here and these voltages, that indicates to me that this is a lithium iron phosphate battery. But that's actually surprising to me because when I took this charger out of the package, it says here 58.8 volts, which is the maximum voltage for a 14S lithium ion, like a lithium NMC or something that might be in here. But maximum charge voltage for lithium iron phosphate is 3.65 volts per cell, which is 58.4 volts for the pack. This is at 58.8. So that's why it's a little bit surprising to me. Maybe they're just relying on the BMS, or maybe they packaged the wrong charger with it. I don't know. I reached out to Bluetti and asked them about the charger voltage. This is their response in its entirety. Pause the video if you'd like to read it. I set up this little camera so that we can capture the moment when this stops charging. So right there I heard it click off and I saw this light turn green. We're at 56.4 but dropping. We're fully charged. I unplugged the charger over here. So let's go ahead and start this capacity test. This is a kilowatt hour meter, so it's going to measure both watts and kilowatt hours. And I've got it hooked up to a 3-prong. Down here we have a space heater and 2 light bulbs. These are 40-watt light bulbs. AC on. And right away some of the lights kicked on. There's the kilowatt hours, that's what's important. 120 volts. So about 350 watts should be perfect. Ideally you want a 5-hour discharge on the battery. Now I don't know exactly how efficient the inverter is going to be with this exact load, and I don't know at what parameters the BMS kicks on and off. There's probably some amount remaining. So having this at 350 watt discharge, that's with 2 light bulbs and the heater, that should be about right. And then once it's done, see we're at 100% right now. But once that's fully discharged, we'll be able to check what this is. And I picked this one up because it has an internal battery, so it'll be able to remember that. Even when this cuts off, we should still be able to see the display. Boy, I think we did it! We hit 1.8 kilowatt hours! Oh, that's great! I didn't think we were going to get 1.8 kilowatt hours out of it, given that this is advertised as a 2 kilowatt hour battery, and then it has to go through the inefficiencies of the inverter, and we have the limitations of the BMS. But we got 1.8 kilowatt hours out of it. Awesome. And it's off! There's the cell voltages. And they're going to start bouncing back now. We did it! The grand total... Oh, come back. The grand total is 1.803 kilowatt hours in 5 hours and 12 minutes. Oh, that's awesome. And AC is off. DC is off. I want to reset this because we're going to... There we go. All right, so we zeroed out the time. We have 0 watts, but also 0 kilowatt hours. Excellent. All right, so I'm going to find out how much it takes to actually charge this unit. So just plugged in the power supply. So this is currently drawing 2 watts, and I just heard it click. And this is bouncing up. So 388 watts. So this is advertised as a 2 kilowatt hour battery, and we pulled 1.8 kilowatt hours out of it. That's a 10% loss. So that 10% is going to get chewed up by the inverter. Now the manual says that the inverter is 88% efficient, but that would be a calculation of 90% efficient. That also means that when they say this is a 2 kilowatt hour pack, maybe that is the usable amount of kilowatt hours. Maybe they're not advertising minus the BMS. I'm going to reach out to Bluetti in an email and find out if they have anything to say about it. Now the reason why I'm saying that is because when I tested this one, this is advertised as a 2.4 kilowatt hour battery, but we pulled 1.9 kilowatt hours out of it. And the reason is that the BMS prevented us from using all of it, and then we also had the inefficiencies of the inverter. This is advertised as a 2 kilowatt hour, and we pulled 1.8. Good morning, everybody. It's the next day. I let this charge overnight. It was actually about midnight that I plugged it in. We're at 100%. Let's see how much electricity it took to actually charge it up. 2.4 kilowatt hours. We brought the Bluetti inside, and it's right next to the fridge. We're going to test a couple of things here. We have the coffee maker ready to go, and that's plugged directly in. Now over here, I just have the power strip simply because this cord for the refrigerator is not long enough to reach all the way up. This power strip is currently off. We're going to be switching that on. We're at 100%. And I also have the power supply plugged in right here. So I want to also see if this works as a UPS, as an uninterruptible power supply, in case the power goes out. I want to find out at what point does this turn on to recharge the battery. You know, does it at 99% then turn that on, or some other percentage? So we're going to try a few things here. Now the fridge should demand cooling right away. So Elena, go ahead and switch it on. I messed up. I forgot to tell you to turn on the Bluetti.
So just the power?
Nope.
Or is there something on here?
Yeah, so there's a touch screen.
Okay.
You have to go to the AC off, and you have to turn that on. There we go. So we heard the fridge turn on, and we heard the Bluetti kick on right away. Now, the fridge draws 140 watts while it's running.
Yeah, I saw a little bit of a surge when we turned it on.
Yeah. So sometimes these portable power packs, even if the inverter is large enough to run the fridge, sometimes it just can't kick the compressor on. This one seemed to do okay. Now let's try turning on the coffee. Coffee is ready to go.
Ooh, that cranked it up.
Yeah. Oh, we just heard a click.
Something clicked, yeah.
Yeah, so that was probably for the charging. And yeah, it went to a red light.
Yeah, that number started to come on.
Right now it's reading 98%. So it's now charging. All right, Elena, what are your thoughts?
I really like the Bluetti. I like the wireless charging. I like the touch screen, and the ports, the covers for the ports, keeps the dirt and dust out.
And the coffee maker just turned off. So now we're just running the refrigerator. So it looks like to make a pot of coffee, we use 10%. I'm going to assume 1% of this was for the fridge. So that means on the Bluetti, you can make 10 pots of coffee. My particular fridge uses about 1.1 kilowatt hours per day. So on a full charge of this Bluetti, we can run the fridge for 1.5 days. I'm just going to leave the refrigerator plugged into the Bluetti for the day. Make sure that this screen doesn't time out or fault out or anything like that. And it's not plugged into the wall. I'm just going to leave it sitting here like it is. 52% of the battery. Kept the fridge going all day, no issues at all. It never timed out, never quit, never overheated, nothing like that. So this worked well. It's the next morning after we took this out of the house last night. Now we're at 51%, same as we were when we took it out. We're about to go hook it up to some solar panels because today is finally a sunny day. I've been waiting for it. Now the MPPT charger built into this has a maximum input voltage of 150 volts. We need to make sure we don't exceed that. Before hooking up a solar charger to solar panels, you always want to check the volts open circuit. Now my panels have a volts open circuit of 47.7 volts. What I do is I multiply that by 1.25. That gives an extra 25% margin for conditions that exceed STC. And then I multiply by the 2 panels I want to put in series. So I can put 2 panels in series and still be under the voltage. So let's go outside and plug it in using the included adapter here for the MC4. I'm setting the Bluetti down on a piece of foam board because everything's better with insulation. One of the panels is at 48.7 volts right now. The sticker on the solar panel says volts open circuit is 47.7. We're already exceeding that, and that's because the panels are so cold right now, being 26 degrees Fahrenheit. The last connection here is going to be the series connection between the 2 panels. Oh, it faulted out for some reason. Still says over voltage. Alright, I think I figured it out. Let's go back here. In this screen, there's a settings, and it says DC input. It says from the car. Well, it's not, it's a PV, so I didn't realize that I had to actually change it in the screen. That's what I get for not reading the manual completely. Alright, so I'm going to clear the fault history so that we can start fresh. And now we have 81 volts coming in at 5 amps. That looks better. Just to clarify one thing, I'm hooking up 2 solar panels to the Bluetti. Each solar panel is 365 watts. That's 730 watts. The maximum wattage that the MPPT solar charge controller built into the Bluetti can handle is 700 watts. It's actually okay to exceed the 700 watts so long as you don't exceed the voltage. What winds up happening is you just don't use all of the available power, but it's okay to hook up the 2 panels. So 2 solar panels in series charging the Bluetti. Now the cables are pretty short that come with it. It works in this situation, but you might want to get some extension cables, and you also will probably want to pick up one of these tools that I had on hand. This is just an MC4 disconnect tool, because these are locking connectors and they are easier to remove if you have the tool. They can be done with pliers, but it's more difficult. 100%. It has turned off the MPPT input right there, and this only took 2 hours, which is fantastic. Now that was from 50% to 100%, so I'm really glad that they upped the MPPT input. The other Bluetti that I tested before couldn't do this much power, and this one can, so that's great. That means it only takes 4 hours to recharge, which is really fantastic. Just for fun, let's go see what the PV is doing. Right now it's at 94.4 volts because it's going to be open circuit because we're not using it. Well, this is great. So let's take it back in the garage and start powering up some tools. Now we're going to get into the testing where we find out where this thing fails. And we're going to overload it. Now I'm sure we can overload it. It's just a question of what do we need to plug in to get it to overload. And that's the fun part. Now it's a 2000 watt inverter, so some things that are 2000 watts will run just fine. Let me give you an example. This is a 1500 watt space heater on high. Now this type of thing is almost 100% just resistive load. There is a little fan on board, so it's not perfect, but it's very close. And if we turn on the AC, we're going to see that this should have no problem. Is the AC on? Yep. There we go. So the heater is on. The screen now says that we are pulling 1525 watts. Now this shouldn't have overloaded that because there's almost no surge involved with this type of operation. So of course it can run it. But when we run saws that are 1500 watts, it might overload it because there's a very large surge. So here's my wet dry vacuum that I keep out here in the garage. It's a rigid model, 6 horsepower, 11 amp. Now it's a relatively small surge as far as power tools go, so I hope that this can power it as well. So let's give it a shot. All right, so 1300 watts. I just ran this yellow heavy gauge extension cord up to my window AC, which is in the garage. Now that's a 5000 BTU Frigidaire window AC. Generally draws about 450 watts while it's running. However, there is a surge involved with air conditioners. That compressor draws a large inrush of current when it first starts up. I just have a remote to start it. When it first starts, it just runs the fan, and then it's gonna kick on the compressor. And it kicked on, and the Bluetti worked fine to turn on the AC, so that's great. So next up is my air compressor. An air compressor takes a really high inrush current. I have a 3000 watt high frequency inverter, and it cannot run this. So I'm not expecting this one to handle it, but if it does, I'll be really impressed. So this has a 14 amp motor. So let's go ahead and try it. Okay, so it did not kick on, so we'll have to release some air. Oh. And it didn't do it, it faulted out. Oh, it's trying again. So the 14 amp is just too much. We are going to find out what the surge rating of the air compressor is. So I'm going to move the Bluetti down and we'll plug it into the wall outlet. By the way, we're currently running this whole building on my off-grid solar system, which is 2 large SMA inverters. You can check out some previous videos if you want more details on that. But the point is that this is not the grid, this is just a really large inverter. To find out the surge rating, we're going to use this tool. And what I'll do is set this meter, so inrush. So it's going to hold that, plug in the air compressor, and turn it on. Our inrush was 43.77 amps, so almost 44 amps. We know that it's a 14 amp motor, so it's 14 amps while running, but it will pull 44 amps during inrush. We now know that the Bluetti cannot do 44 amps at inrush. Let me pull the shop vac cord over here and we'll just run the shop vac also. That way we know what it can do. We'll try to narrow the can't to the can, the go, no go, and we'll find out kind of where the threshold is. We'll find out the shop vac. There we go. 33.2. So the wet dry vacuum, or shop vac as a lot of people call them, drew 33.2 amps during its inrush. So we're getting a fairly small margin now of what the Bluetti can and cannot power. Now my miter saw I think draws even more amps at inrush, but we'll try it anyways and see if it works. My miter saw is a 12-inch sliding compound miter saw, so it's a large miter saw. It's DeWalt model DWS780. So let's go ahead and plug it into the Bluetti, see if it'll start. It probably won't. Can you see it now? All right. What? I was not expecting that to start. So let's try that again. Yeah. So I'm really surprised that it started. I wasn't expecting that. Let's find out what the inrush is. The inrush on the saw is 66 amps. So that is more amps than the air compressor, but this Bluetti could not start the air compressor, but it can start the miter saw. So, hey, I'm not an electrical engineer, but if you know why that is, please leave a comment below. This is a big chunk of oak. I taped on my wet dry vac on the back side, but that is plugged into the wall outlet of the garage. So I'm going to turn that on first, but that's not plugged into the Bluetti. So the Bluetti is just going to power the saw. Okay, here we go. Okay. So it did fault out. It's beeping at me right now. Now, to be fair, I did push it. I tried to make it stall out, but I can push it when it's on the grid and it doesn't stall out. So let's try it again, and I'm gonna make a new cut in the oak, but I'm gonna go gentle, and hopefully that can keep running. Oh, but it still faulted on me. It was beeping. All right, so it was able to do it, but it wasn't happy. It must have been right on the verge, and I went really slow with that one. I would not purchase this Bluetti with the intention to use large power tools like this on it. This is not the intended use case for this type of tool. Now, this type of unit is far more appropriate for charging cordless tool batteries. I have some DeWalt cordless tool batteries, I have a couple of Milwaukee, and I have some Cobalt 40 volt stuff for my gardening tools. Now, this is way more appropriate for that type of thing in your truck or trailer with a couple of solar panels and be able to recharge your cordless tool batteries in the field. You can also use it in an off-grid cabin scenario. It'd be good for that. But let me go ahead and plug some of these in. With 3 tools all charging, we're now drawing almost 400 watts. Running lights, TV, computer, cordless tool battery recharging. This is more appropriate for what this is designed for. Okay, right now I have this really dangerous cord plugged into the Bluetti so that we can see the oscilloscope. I believe battery chargers and LED lights and compact fluorescents, I think they're called non-linear loads. And that's why you kind of get the top chopped off here. So let me see what it looks like when we take these out. See, that is a beautiful, perfect sine wave off the Bluetti. But as we start plugging in loads that are non-linear, it's going to get a little bit worse. It's just going to chop off the top. Not bad, but something to be aware of. So let's go ahead and plug these back in. All right, so as we're charging these 3 batteries, and we have almost 400 watts coming out, we can see that the top and bottom of those sine wave, the peaks and valleys, they are getting chopped off. And it does that because that's how these take the power. They're just taking the very top and very bottom and converting it to DC. Now I'm going to turn this on, but I'll keep the camera up here on the oscilloscope. Shot vac. I'm going to turn this on one more time so that you can watch the screen. So we did go over 2,000 watts for a brief moment. It didn't actually shut off, but it does look like it went to fault. So in the manual it says 2,000 to 2,500 watts for 2 minutes. And so we were less than that. I think that's probably it for testing. I'm actually really impressed with the Bluetti. They did provide the unit at no cost to me for the purpose of a review, but the thoughts and opinions here are my own. We have to be realistic about the category that we're talking about. This unit weighs 60 pounds or 20.5 kilograms. I don't expect this type of unit to run large, heavy power tools, but I do expect it to put out a clean sine wave, charge my cordless power tools without damaging them, TVs and lights and computers and refrigerators and deep freezers. And it can do all that in just 4 hours of decent sunlight. You can recharge this pack all the way, and that's really great. It's a 2,000 watt-hour battery. Well, actually, it's a little bit more than that, but it's 2,000 available to us. Minus the inverter losses, we got 1,800 watts out. So they've done a good job overall. So a couple of improvements with the battery. It's now a lithium iron phosphate chemistry, and they've done it in a 16S, so that's going to be a 51 volt nominal. So I find the cords a little quirky, but at least they did provide the MC4 connections. These are really important to me because if I'm going to buy something like this, I want to charge it with solar, and they provided the adapters for that. I think this unit sells for $1,900. So I really hope that this video helps you in your buying decision so that you know what this can do or what it can't do. Thank you everybody so much for watching. Please like, subscribe, and comment and share. Thanks.